Chapter 4, the carbohydrates. These are your learning objectives for this chapter. This is a continuation of the learning objectives. Carbohydrates are made up of carbon, hydrogen, and oxygen. Carbohydrates are characterized by the number of saccharides or sugars they have. Mono equals 1, di equals 2, and poly means many or multiple. They are also characterized by simple versus complex. Simple would be your mono and disaccharides, or known as the sugars, and complex carbohydrates are your polysaccharides. They include starches and fibers. Monosaccharides are our single sugars. Your three monosaccharides are glucose, fructose, and galactose. Glucose is the essential energy source for your brain. It's also known as dextrose, and it's a form of sugar in blood. It's part of every disaccharide. Fructose, naturally found in fruits and honey, it's added to many foods as high fructose corn syrup. Galactose rarely occurs naturally as a single sugar. It normally exists with glucose to form lactose. Disaccharides refer to a pair or two monosaccharides, one of which is always glucose. You have maltose, which is glucose and glucose. Barley is the most notable source. Sucrose is glucose and fructose, can be refined from sugarcane and sugar beets. Lactose is a combination of glucose and galactose, and it's the main sugar in milk. We have two reactions, condensation and hydrolysis. So condensation links two monosaccharides together and releases water. Hydrolysis does the opposite. It breaks a disaccharide into two and it uses water. Here, this is an example of a condensation reaction where you're bringing two separate monosaccharides and they're coming together to form a disaccharide. So you bring those two molecules together, it releases water. This is a condensation reaction. This here is an example of hydrolysis, which if we remember is a breaking or a splitting, and it requires water. So hydrolysis splits the disaccharide into two monosaccharides. The hydrogen and the oxygen-hydrogen molecules of water, so H2O, complete the two monosaccharides so they can split. Please pause the presentation momentarily and see if you can fill out the correct answers. Moving on from simple to complex carbohydrates. Complex carbohydrates are made up of either few glucose units, known as oligosaccharides, or many glucose units, polysaccharides, bound or linked together in straight or branched chains. Types of polysaccharides include glycogen, starch, and fibers. Glycogen. This is the stored form of glucose in humans. Manufactured and stored in the liver and muscle, glucose units in highly branched chains provides a rapid release of energy when needed. Starch, that is the stored form of glucose in plants. May be long and branched or long and unbranched chains of glucose units. We'll see an example of this on the next slide. When consumed, the body hydrolyzes the starch to glucose. You can find these in grains, tubers, and legumes. Here's a visual comparison of glycogen and starch. On the left, you see glycogen, which is a highly branched chain of glucose. On the middle and to the right side, you have amylopectin, which is occasionally or highly branched chains of glucose, and then amylose, which is unbranched chains of glucose. Please pause the presentation momentarily and see if you can fill in the blanks. Dietary fibers. Fiber is a structural part of plants. Fiber differs from starches in that the bonds cannot be broken down by human enzymes. Therefore, they do not provide calories. Fibers are either soluble or insoluble in water. Health benefits from soluble fiber. Typically, they can be helpful for issues like heart disease, diabetes, cancer, and weight management. And some health benefits of insoluble fiber are primarily geared towards your GI health. Functional fibers. This is when fibers are extracted from plants and added to foods or used in supplements. So cellulose, naturally found in cereals, is a dietary fiber because it's supposed to be there, it's natural. Cellulose that's extracted and put into a supplement, be it a powder or a pill, let's say, and used to alleviate constipation, is considered a functional fiber. Soluble fiber. Soluble, non-starch polysaccharides that dissolve in water to form a gel. For example, pectin from fruit helps thicken jelly. Types of soluble fiber include hemicellulose, pectins, gums and mucilages, as well as psyllium. I'll let you read the sources. Health benefits of soluble fiber. Soluble fiber binds with bile acids in the GI tract and therefore increases excretion. Now the liver uses its own cholesterol to make new bile acids, therefore lowering blood cholesterol and decreasing the risk for heart disease. Slow stomach emptying provides a feeling of fullness, which can help with weight management. If you feel full, you'll be less likely to overeat. Soluble fiber slows transit through the GI tract, slowing glucose absorption, and therefore prevents a glucose surge and rebound. So this helps for people who have diabetes. It also holds moisture in stools, which can help with elimination. If you have hard stools, it can be very unpleasant to be constipated. Insoluble fiber. Insoluble fiber does not dissolve in water and does not form a gel. Types include cellulose, hemicellulose, lignin, and resistant starch. Health benefits of insoluble fiber: speeds up fecal passage, increases fecal weight, aids in elimination, and alleviates constipation. Lowers risk of diverticulosis, hemorrhoids, colon and rectal cancer. Binds and rapidly removes cancer-causing agents from the colon. Recommended intake of fiber. So the DRI recommendations are for about 14 grams of fiber per 1,000 calorie, or about 25 grams for an adult woman, or about 38 grams for an adult male. They recommend a variety of plant foods, be it whole grains, fruits, vegetables, nuts, and legumes, which also provide vitamins and minerals, phytochemicals. Fiber supplements do not have the same health benefits as fiber from whole foods. You'll want to note that it is important to increase fluid intake when increasing fiber. Negative effects of fiber. So, while fiber has many health benefits, too much of anything is not good. If eaten in excess, it can have negative side effects like abdominal discomfort, gas and diarrhea, GI obstruction, and interference with nutrient absorption, especially minerals, with consuming greater than 40 grams per day. Please pause this presentation and see if you can match these appropriately. Carbohydrate digestion in the GI tract. Initial carbohydrate digestion starts in the mouth. You have salivary glands that release saliva containing amylase, which starts that breakdown. Carbohydrate digestion stops in the stomach. Fiber delays gastric emptying, which provides a feeling of fullness. And carbohydrate digestion stops in the stomach due to the high acidity from your hydrochloric acid or stomach acid. Carbohydrate digestion starts again in the small intestine, and most of your carbohydrate digestion will occur here in the small intestine. Pancreatic amylase enters via the pancreatic duct, and breakdown of polysaccharides continue. Fiber attracts water in the large intestine. Digestion of carbohydrates. So this is basically a summary slide. So the goal of carbohydrate breakdown is to release glucose. Monosaccharides do not need to be split because there's only one. It's a single sugar. Disaccharides need to be split once, again because it's two, so it only needs one split to break it apart. And starch requires extensive breakdown because it has multiple saccharides. I encourage you to pause the presentation momentarily and see if you can fill in the blanks. Again, please pause the presentation momentarily and just see if you can match these appropriately. Lactose intolerance. So lactose, if you recall, is a disaccharide containing glucose and galactose. Lactase is the enzyme that breaks down lactose. Lactase activity is highest immediately after birth and declines with age. Only about 30 to 35% of adults have lactase. Symptoms of intolerance can include things like bloating, gas, abdominal discomfort, diarrhea. Undigested lactose becomes food for intestinal bacteria, which multiply and produce symptoms. Intestinal damage from diseases, certain medications, and malnutrition can lead to decreased lactase. So those are additional causes beyond age. Dietary changes with lactose intolerance. Manage dairy intake rather than restrict intake. You might be able to consume up to 6 grams of lactose or about half a cup of milk without symptoms. Fermented milk products like yogurt, kefir, and cottage cheese may be well tolerated as bacteria digest lactose for their own use. Individualized diets. So you may use Lactaid milk or Lactaid tablets, which contain enzymes to break the lactose down. Other non-dairy products might contain lactose like bread, cereal, breakfast drinks, salad dressings, and cake mixes. Potential nutrient deficiencies include potassium, vitamin D, and calcium. Carbohydrate metabolism. The primary role of carbohydrate in the body is to provide the cells with glucose for energy. If you recall, glycogen is the stored form of glucose. Now, the liver stores about 1/4 of the body's glycogen, and muscles store the other 3/4. For the liver, it releases glucose into bloodstream as needed. If your body is in a state of long-term deprivation, the body will use fat for energy. So the liver stores about enough for roughly 1 day. Your muscles store the other 3/4, and it uses glucose when exercising. Excess glucose gets stored as fat. Gluconeogenesis is the conversion of protein to glucose. It occurs when there is inadequate carbohydrate consumption. This occurs when the glycogen stores are depleted and the body needs to create new glucose. Recall that glucose is the preferred fuel source for your brain, nerve cells, and red blood cells. Fat cannot make glucose to any significant extent. Amino acids of protein can make glucose, but their primary roles are for other things in the body. If there's not enough carbohydrate, the body will break down protein from the liver and skeletal muscles to make glucose for the brain and other nerve cells. Carbohydrate metabolism. With continued inadequate carbohydrates, abnormal fat metabolism occurs as the body attempts to provide an alternate energy source and prevent further breakdown. Ketone bodies are produced from fat fragments created during this abnormal fat metabolism. Ketone bodies produce alternative fuel source during starvation, but when production exceeds their use, they accumulate in the body, causing ketosis. So ketosis is the accumulation of ketone bodies in the blood. You need about 50 to 100 grams of carbohydrate a day to prevent ketosis. Glucose in the body. Maintaining glucose homeostasis. Constant level of blood glucose is necessary at all times to allow cells to nourish themselves. Potential issues if we don't maintain glucose homeostasis includes low blood glucose, which may cause dizziness, headache, and weakness. High blood glucose may cause confusion, headache, fatigue, and long-term may experience vision problems, thirst, and increased urination. Extreme fluctuations, be it high or low blood glucose, can be dangerous. When blood glucose regulation fails, the result may be hypoglycemia, or low blood glucose, or diabetes. Diet planning is important to prevent this. So how do we maintain blood glucose control? It's regulated by 2 hormones. First being insulin, which moves glucose from the blood into cells. Next, you have glucagon, which brings glucose out of storage when needed. Steady supply in bloodstream. So how do we do this? You have the intestines, where they get carbohydrate from food. So eating balanced meals regularly with adequate complex carbohydrates can help keep blood glucose levels within normal range. The liver stores glycogen, and glucagon, the other hormone, acts when blood glucose levels fall, perhaps between meals, and it signals the liver to break down its glycogen stores and release glucose, which in turn raises blood glucose levels. Insulin is released when we eat in response to the rise in glucose. Insulin works to get glucose into the liver and muscles to be stored as glycogen, as well as get glucose into cells for use. Glucagon and epinephrine breaks down glycogen to glucose. The fight or flight hormone, epinephrine, signals to the liver to reduce glucose for energy in stressful situations, so the cells have energy. For example, if you see a bear, you need to run. Maintaining blood glucose homeostasis continued. So this is a chart I'll let you read over yourself, and it simplifies and kind of puts into perspective what the steps are and what the goal is for the body to help maintain homeostasis. This is a summary slide, again, just putting into words what is happening. So blood glucose rises when we eat. The pancreas will release insulin, which then glucose gets taken into cells. Your liver and muscles make glycogen. Any excess glucose will get stored as fat. Eventually, blood glucose declines, and after a few hours of not eating anything, the pancreas releases glucagon to the bloodstream. And then the liver breaks down glycogen to glucose, and glucose gets released into the bloodstream, and blood glucose levels rise again. I ask that you pause the presentation and see if you can fill in the blanks. Again, you can pause the presentation momentarily before I reveal the answers. And one more question. Recommended intakes of sugars. So we've updated food labels that separately list added sugars. This helps consumers make healthier choices. Food labels include added sugars now because previously it was just total sugars, which included both added and naturally occurring. How to estimate sugar? So 1 teaspoon of sugar provides about 4 grams of carbohydrate and about 16 calories per teaspoon. So if you want to look at a food label, you would look at the total grams of sugar in that product and divide that number by 4. And that's the number of teaspoons of sugar. Added sugar, so less than 10% of energy intake. That's what the dietary guidelines for Americans suggest. And then they also note 5% or less would be even more beneficial because it's less empty calories and more nutrients. Alternative sweeteners. Artificial sweeteners give food sweet flavor without calories. That's why it's called a non-nutritive sweetener. Large doses can have adverse effects, including GI upset, feeling hungrier later, and there's mixed research on overall blood glucose control. Stevia is an herbal product. Both stevia and monk fruit have been used for a long time in South America and China. They are generally regarded as safe. Sugar alcohols, or polyols, do provide calories, and sometimes they are called nutritive sweeteners because they do provide some calories. Benefits, they do not contribute to dental caries or cavities, so it's good for chewing gums and mints because bacteria in mouth cannot metabolize it. But side effects potentially include unabsorbed sugar alcohols may be metabolized by bacteria in the GI tract, causing gas, bloating, and diarrhea. Health effects and added sugars. In the US, about 50% of the sugar we consume comes from fruits, vegetables, milk, and grains. The remaining 50% comes from added sugars, highest amount coming from sugar-sweetened beverages. Added to foods for taste, texture, bulking quality, microbial growth inhibitor, yeast fermentation, etc. Adding sugar can help prevent bacteria growth and spoilage. Excess consumption of these added sugars can have health effects, including obesity, hypertension, inflammation, diabetes, heart disease, and dental caries. And as a review, I ask that you please pause the presentation before I reveal the answers, and this will conclude Chapter 4.